Hi, welcome to this video. In this video, I'll show you guys how to sketch, how to make a sketch for this f of x. Okay, so on the screen, you see this f of x. It's a pretty complex rational function. So we talked about rational function already. And this is a little bit more complex than what we learned before. But now that we know calculus, we can sketch this complex rational function. So let's give that a try. So let's try to find if we can find the asymptotes. So the asymptotes, and if possible, let's try to find the x and y intercepts. Yeah. So asymptotes is when I have the denominator. So I will have something over 0. And in this case, my denominator will never be 0, so I don't have any asymptotes. Okay. And let's see what else. For my x and y intercept, if my x is equal to 0, to find the let's start with the y intercept. To find the y intercept, I'm going to make x equal to 0. So when x is 0, my y would be, so I will have 0 minus 1, I will have negative 1 over 0 plus 1, which is 1. So I would have negative 1. So that's my y-intercept. And for my x-intercept, I'm going to make this equal to 0. I'm going to have y is equal to 0. So I will have to solve this. X squared minus 1 over x squared plus 1. This is equal to 0. And this will only happen when my x is equal to 1 or negative 1, right? So if I have 1 in here, then 1 squared minus 1 gives you 0. If I have negative 1 in there, I will also get 0. So there you go. So I will have two x-intercepts, negative 1, 0, and 1, 0. Okay? So all this, kind of the key features over here. The key features over here. I'm sure you guys know how to do this, yeah? So let's continue. So to find f prime, now I have pretty much got all the key points that I need, and we first analyze if there's any asymptotes. For now, it doesn't look like we have any asymptotes, but we do have some intercepts, x and y intercepts. So, and we already got the points. So that's all we can do, pretty much, with the f of x. So let's continue on with my f prime. So if I get f prime, I will have to use the quotient rule. It'll be x squared plus 1 squared. And since we're applying quotient rule, I'm going to assume that you guys know how to apply the quotient rule. If not, please go back to your notes and refer back to the exercises that you did earlier on. So I'm gonna have x squared plus 1, differentiate the numerator, I get 2x, minus, I'll have x squared minus 1, differentiate the denominator, I'll get 2x. And if I simplify this, I will have x squared plus 1 squared for my denominator. And I'm going to distribute what I have here. Yeah, so I have 2x cubed plus 2x. Distribute here, and don't forget the negative in the front. So I will have 2x times x squared times the negative in the front. I'll have minus 2x cubed. 2x times negative 1 gives us negative 2x times the negative 1 in the front, plus 2x. So I can further simplify this as 4x over x squared plus 1 squared. Okay? This gets cancelled out. Yeah. Okay, so now we have the expression for the derivative, the first derivative. We need to find the critical points, right? The critical points. So 4x over x squared plus 1 squared is equal to 0. And this is what we have been doing so far, right? We have been equating my first derivative expression to 0 to find the critical point. But don't forget, there's also another way to do this, which is when is this equal to undefined? Yeah. So let's do the equal to 0 first. My numerator will never be 0, right? It will never be 0. Also, I'm sorry. My denominator will never be 0. So which means it has to be 4x equals to 0. Okay. Which means x has to be equal to 0. Now, in order for me to have, let me change to blue. My blue writing means undefined, the undefined scenario, okay? So in order for me to have undefined, I can have whatever on the top over 0. My denominator must be 0. And because of, if we didn't have the squared there, then my x is -1. That would be a critical point, yeah? Because when I have -1 in here, then this whole thing becomes 0, and then I will have something that's undefined. So this -1 is a critical point. But that's not the case, because we have this squared. So if you put a -1 in there, -1 squared becomes +1. So plus the 1, and you apply the square at the outside. So the whole point is we will never get this. This is not possible, yeah? This is not possible in this case. So you need to do a little bit of analysis, okay? This is not possible. So which means that's your only critical point, right? That's your critical point. So if the undefined scenario is not possible, I'm just going to erase that. So what you guys should do is you make sure you have a scrap paper, right? So so that you can the workings that I erased just now, that should be done on scrap paper, yeah? Because the undefined scenario does not apply. So x equals 0 is a critical point. This is my critical point. And I will carry on. I will create the sign diagram in the end. So I'll carry on with my second derivative. So let's carry on. I'm gonna use red for my second derivative, the workings for my second derivative. So this is my f prime. So for me to get my second derivative, I'm going to differentiate what I have here. Right? So same thing, quotient rule. So I'll have x squared plus 1 squared, and that whole thing squared. And I will have x squared plus 1 squared. And if I differentiate the top, I'll get 4 minus, I'm going to keep the 4x, and I'm going to differentiate the bottom, right? This is quotient rule. I'm simply applying quotient rule. So I'm running out of space, so I'm going to adjust the zoom a little bit, yeah? So if I differentiate the bottom part, I will get x squared plus 1. That's the box outside, yeah? Oh, sorry, actually, my bad. That's not x squared plus 1. That is actually 2x squared plus 1. And then multiply it by whatever is inside, which is 2x. Sorry about the size. I did not plan that well. But hope you guys understood what I'm doing here. Okay, so let's continue. Then let's try to simplify this whole thing. So I will have to apply the power to the power, and that gives us x squared plus 1, the whole thing to the power of 4. And over here, I will have 4 times x squared plus 1 squared. And over here, I will have minus 4x. Let's take this slow. just to make sure we all get it. Okay. Let's see what else we can do. So here we can distribute that. I'll get 16x squared. Minus 16x squared multiplied by x squared plus 1 over x squared plus 1 over 4. Okay, now I'm going to highlight some stuff so that it's easier for you guys to see. I have x squared plus 1 over here, and I have x squared plus 1 over here, right? Which means that's something that we can factor out. I have a 4 here, I have a 16 there, so we can factor out something from there as well. Okay, so let's try to factor it. This is equal to, wow, this is taking quite some time, huh? So x squared plus 1 over 4, sorry, to the power of 4. I'm going to take out the 4, take out the x squared plus 1, and then see what's left in there. If I take the 4's out, right, the 4's out, and I have 2 of x squared plus 1, that's squared, that's what I have. So I took 1 out, I'm going to have x squared plus 1 left in there. So when I distribute this whole chunk in here, I will get that. Okay? If I'm going too fast, please rewind the video and maybe play in slow motion. Okay. Now let's work on this part. This is the part that we're gonna work on. So the negative 16x squared, we already took out the 4, so I'm gonna have minus 4, and then we also took out the x squared plus 1, right? So there's no more x squared plus 1 left, which is minus 4x squared. Okay, and this is pretty nice because I have x squared plus 1 here, and I have x squared plus 1 at the bottom, so that becomes 1, and this becomes 3. So almost done here. This is x squared plus 1 to the power of 3, and I have 4 on the outside, and in the inside, x squared plus 1 minus 4x squared, I would have minus 3x squared plus 1. Yay, we're done. So that is my expression for my second derivative. Alright, that's the expression for my second derivative. That took us a while. So, same thing, let's try to find a critical point. So if I make this equal to 0, I'm gonna utilize my space over here, yeah? So I'm gonna bring this up here. So I will have 4 over negative 3x squared plus 1 x squared plus 1 over 3 equal to 0, right? That's how we find the critical point. And then we will analyze if we have this scenario, yeah? So let's analyze the equal to 0 scenario first. So in order for me to get the 0, the numerator must be 0, and is that possible? So it's only possible when I have negative 3x squared plus 1 equal to 0. So I have negative 3x squared is equal to negative 1. My x squared is equal to 1 over 3. So my x is equal to plus minus square root 1 over 3. Okay, yep, so I have 2 points. Let me write them separately, maybe that's better. So my x is equal to 1 over 3, or, square root of 1 over 3, or negative square root of 1 over 3. And they're just values, right? One is positive, one is negative because of the square root. So here I have 2 critical points, right? And that's it. Those are the 2 critical points that I get from the equals to 0 scenario. Now for the undefined scenario, is it possible? So, which means, is it possible for us to make the denominator 0? So, you can pause the video, think about that. The answer is no, right? It doesn't matter what we put in here. In order for us to get this denominator equals 0, my x squared must be negative, right? So negative 1 plus 1 gives us 0, and that's when we get a denominator of 0. But because of the squared, there's no way we can get a negative, therefore we can't. So this, we don't have to worry about the undefined scenario. Okay? All right, nice. So now we are done with, we have, for my first derivative, I have one critical point at 0. For my second derivative, I have two critical points. Yeah, these are my critical points as well. So let's start sketching. Before we do that, I'm going to create a sign diagram. The sign diagram is very, very helpful. Yeah. So my values are 0. So I'm going to start with 0. Negative root 1 over 3. And this will be root 1 over 3. My f prime, f double prime. So for my f prime, this is prime, okay? This is my first derivative. For my first derivative, I don't really have to worry about my the square root, yeah, because that's only for my second derivative. So my first derivative, I just analyze it with my 0. And let's say if this is negative or positive, or this is negative or positive, yeah? We'll see what the signs are. So let's see. I'm going to test, so let me write the test values in blue. For the f prime, I'm going to test with, say, negative 1 and 1, okay? So I'm going to look at my second derivative expression. My second derivative expression is over here. And when I substitute negative 1 in here, my numerator will be negative, my denominator will be positive. So overall, I will get a negative. So this is negative throughout. Okay? Oh, sorry about that. And for 1, if I put the 1 in here, then I will get positive on the top and positive at the bottom. So overall will be positive. So this is positive throughout. Yeah? So that's it. That's it for my first derivative. Now for my second derivative, I need to test with something else. 1 over root 3, square root of 1 over root 3. The value for that is about 0.577, or you can almost 0.6. So this is approximately negative 0.6. So this is approximately positive 0.6. Yeah. So the reason why I'm converting them to decimals is so that we know decimal places, so that I know what test values to use. So over here, I would test with negative 1. Right? And over here, I would I'm just going to write the test values on the number line, okay, so that you guys can see easier. I'm going to test with negative 1. I'm going to test with negative 0.5. This I will test with 0.5, and I will test with 1 over here. Okay? Actually, I made a mistake here. There is no need to test the negative 0.5 and the positive 0.5, because for my second derivative, I have these sections. So I can test with negative 1, that's okay. I can test with 1, and that's okay. I can test with 1, that's okay. I just need one test value over here, and I can test with 0. What's wrong with that? Because that's a critical point for my first derivative, but I can use that for my second derivative, right? I can use this to test if this is positive or negative at 0. Why not? But if you don't feel comfortable doing that, you can test with 0.5 if you want to. That would work. Yeah? But again, there's nothing wrong with using 0. Okay, so let's do this. So my expression, now the test value is -1, so my expression is over here. If you put -1, my denominator becomes positive. My numerator, -1 squared becomes positive. -3 plus 1 is negative, times the positive, so this will be negative. So that will be negative. So negative, and this is also negative, yeah? So let me erase this. So now I can improve my sign diagram. And I'm going to test with 0 for my second region here. So my second region 0, if I have 0, then I have, if this is 0, then I have positive, because 0 plus 1 is positive, times the 4 is also going to be positive. So I have positive over positive, so this will be positive. Okay? If it's 0, it will be positive. Nice. Now, lastly, I'm going to test with 1. If I test with 1 over here, if there's a 1 there, then I will have negative on top, and I'm still going to have positive at the bottom, so this will be negative. So let's make this sign diagram better. So this is positive. I can erase that. This is also positive. And now I can have the different regions. Right. I can take that out. Oh, I can take this out. Yep, that's it. Okay. Now this is positive, negative, positive, positive, negative, positive. That's it. Okay, that's it. Now we're almost done here. So let's sketch. So I have a bunch of key points. We will sketch this point, sketch this function in class together. But I want you guys to try to make your sketch. Okay, try to make a sketch from this sign diagram, and then I will make the sketch again in class using this sign diagram. And I think that's all we need to know for graphing derivatives. Yeah, guys. Again, I'm really. If you guys understand the stuff that I've been talking about here, that's really impressive, yeah. But I hope you guys, there's a lot of stuff here to be covered, to be analyzed, right? This is really some pretty rigorous math here. So try to, in your notebook, do what you can to write your own notes, annotate stuff that you need, so that when we are close to the exam period, when it's time to review, we still remember the stuff here, yeah. So if you need to review on quotient rule, chain rule, whatever rule, do that, yeah. But if you guys understand the stuff that we have done so far in the video, I am a happy teacher, yeah. Be proud of yourself. Try your best to make the sketch, and I'll see you guys in class. Bye bye.